Hi, welcome to Functional Justin. This is the third video in the series, and last time we showed how to implement a Scala 2 type class, and this time what we're going to do is use that type class in the evaluation function from my first video. So in the first video we had some code that evaluates an expression given an abstract syntax tree, and it was limited to integers. And so what we're going to do is use the numeric type class we did last time so that we can use different kinds of numbers in our evaluation. Okay, let's get started. Okay, so in the last video we saw how to implement our own copy of Scala's numeric type class, and so what you can see here is just that numeric type class. We've got some instances, we got some implemented instances for that type class, and we've got the ops, and we've also got something I didn't really talk about. This is sometimes called a summoning function, but it just gives us a way to, whenever we have an implicit numeric, we can just call this using numeric t, and we'll get a numeric to work with. So what we're going to do in this one is I'm going to take the expression evaluator from the first video and convert this to use the numeric type class instead of integers. And just as a recap, what this expression evaluator does is quite simple. First of all, we have this abstract data type that represents the different parts of an expression, and so an expression can consist of four things. The first one is the simplest, is a value, and that's just a wrapper around an int. The second one is an expression that can give you the sum of two expressions, so that's the add function. The third one is mul, which gives you the product or multiplies two expressions. And var is a variable expression which takes an identifier, so it looks up the value of the variable in a symbol table. And the symbol table is just a map of string to int. Then the actual expression evaluator itself is just a recursive function, or it's a set of mutually recursive functions. So it takes an expression and an environment. Looks like we're sneakily using Scala 3 here. Let's just go back in time to Scala 2. So the expression is evaluated. Has an implicit symbol table while it's doing the evaluation, and at each step it either returns a value or it recursively goes into the expression tree to calculate the next value. So this is what an expression looks like. It's just it's just a nested tree of expressions. So in this one we have we have the variable z. We're going to multiply z by the sum of 30 and the product of x and y. Right, so if you do this in your head, you'll get the answer 400. And this is an example symbol table. So we can just run this. So that's going to compile in the background and run, and then you can see that the value is 400, so everything's working. So first thing we need to do is we're going to bring in our numeric class. So I believe we called it Scala 2 numeric. And we're also going to need the operations. So we're going to bring in Scala numeric ops. And then our expression itself needs a type parameter, because we don't want it to be fixed with integer anymore. So we're just going to add a type parameter, and then we're going to need a type parameter for each of our four operations. And then also on each of these return values, we need to pass the type parameter to the expression parent type, and each of these as well also needs to be parameterized. So far all we're doing is simple copying and pasting to change that data type. Now an environment is no longer going to be hard-coded with integers, it's going to also be type parameterized with type t. So this will also be a t. And now our evaluation function is going to need another implicit because it's going to need a numeric instance of type t. Alright, so the first thing we're going to do is add that second argument. And then of course val itself needs to be parameterized. And the expression needs to be parameterized. And so does that. So far we're just copying t's everywhere. So that takes care of our main evaluation, and then the evaluator calls these helper functions to do its work. So obviously these things are going to be parameterized too. And then our expression here needs to be parameterized, so we're going to just, at this point, we're going to use a concrete type, the integer, and same with this one. Okay, so far so good. Now we have a couple of errors. So handlevar still wants an integer, so what did I do wrong there? Handlevar, yes, I see. We didn't tell it to return a t. In fact, all of these functions, we should make it clear that we want a t back. And it goes the same with this. Alright, so next we have the problem that value is the wrong type. It should be a t. Mr. T, yeah, Mr. T. Alright, so that one's good. And now what's wrong here? No implicit for numeric. There should be an implicit for numeric. There should be. Maybe the problem is that I haven't yet added this as an implicit parameter. That's better. And same there. Now this one, we're going to change this a little bit because well, there's two ways to solve this. If a symbol table has no value, we used to return 0, but now we don't have 0. So the long way around would be to define 0 for numeric, which is, you can easily do that. But what I'm going to do, just because I don't care about this program, is I'm just going to replace it with a get. So what happens here is we look it up in the symbol table, but if we don't get the value, then we're just going to crash, which is, you know, not ideal. I think this is actually equivalent to this. Okay, so that works for me. Now I'm going to compile and run, and you can see that it still works. So let's try and do something weird. Right? Remember I made, in the last video, I made a numeric of type string, so we can do an arithmetic on strings. So let's try an example of that. So I'm going to make implicit environment of strings. and we'll have a variable called x, which just contains a. And we'll have a variable y that just contains b. And then we're going to evaluate an expression. And the expression is going to be of type string. And what we're going to do is what we're going to do is just multiply, let's say we'll multiply x by y. I'm just going to move that up there, and then we're going to evaluate expression 2, print it out. Okay, now we can see what a times y looks like. There we go. So a times b is ab. And just to make it more interesting, yeah, now we have lots of abbas. Okay, so what did we do in this video? We used our type class we made in the last video, and we made our expression evaluator more useful, more interesting. And what we'll do in the next video is go back to the numeric class and show how Scala 3 has made type classes much more simple to both implement and to understand. Thanks for watching. Bye bye.